All right, hello everyone. Today we're going to do number-based conversion with Horner's scheme. So this scheme I know is a little bit confusing at first, but once you get the hang of it, it'll make it a lot easier to convert between number bases that maybe aren't as intuitive to do. I mean, generally we like to look at one base, convert it into base 10, then convert it to the other base because it's just easier for us to understand, right? But when a computer is actually doing conversions, they're probably not going to be doing that intermediate conversion because base 10 is just something that we're comfortable with, right? But it doesn't have to necessarily be that way. Now, we'll do this method because it'll make it easy to convert between some random bases. So let's try this out. This first example, we've got 11,201 base 3, and we're going to convert it to base 7. So we're going from a small base to a larger base. Now, how are we going to do this? Let's first rewrite our number, 11,201, into a format that's a little bit easier for us to calculate things. And it'll kind of be like factoring out the threes in this case. So what I mean by that is let's take the first digit, let's multiply it by the base, okay? And let's add the next digit, so that's 1, 1, 1, 1. Let's put parentheses around that. Let's multiply by the base again, add the next digit, which is 2, parentheses again, multiply by the base, add the next digit, which is 0, parentheses again, multiply by the base again, and then finally we add the last digit. So we've got all of our digits. We have 1, 1, 2, 0, 1, 1, 1, 2, 0, 1, and we've got 1, 2, 3, 4 threes. So this kind of makes sense actually, because if we look at the first digit here, 1, it's being multiplied by 3 4 times. You see 1, 2, 3, 4. And this is kind of what we would expect, right? Because if we look at the actual number, 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, that 1 is in the 3 to the 4th place. And this one here would be in the 3 to the 3rd place, right? Because you've got 1, 2, 3. And the 2 is in the 2's place, 3 to the 2's place, and so on. So this is kind of what we expect. It's just a little bit, weird looking at it in this form. But if you remember how to at least expand the number in this way, then everything else that comes after shouldn't be too hard. So now that we've got this, we want to immediately start working in base 7. Okay, so stop thinking base 3. We've got a number in a specific format. Let's work in base 7. Now, what is base 7? Well, base 7, what do we have? We have the values 0, 1, 2, 3, 4, 5, and 6. Now, the key thing to note here when we do this calculation is essentially we're going to work from the inside out. We're going to start from the inner parentheses, go to the outer parentheses, outer, until we reach the end. And if any of these calculations, like these internal calculations, exceed our capacity for base 7, right, if it results in a value of like 12, for example, we would have to convert that 12 into base 7 and then do some arithmetic with that. Now let's actually get into this so that we can see how it works in practice. So let's do this conversion. 3 plus 1, 1 times 3 is just 3, plus 1 is just 4, and since we have 4 as one of the digits in base 7, that's okay. So we'll say that the result of this little parentheses here is 4. And then what's next? Well, we're going to multiply by 3, right? And what's 4 times 3? It's 12, but of course 12 does not fit in our base 7 system. So we're going to need to convert it into base 7 so that it has only digits from 0 to 6. So how do we do that? Well, what is 12? 12 is just 7 plus 5, right? And if we write it in this format, 1 times 7 to the 1 plus 5 times 7 to the 0, you might recognize this from binary, but you just take these two values here and you say, okay, that means that it's 15 base 7. So you just look at these two. So that means that 12 is actually 15 in base 7. So let's write that out here. So that means this is 15. But of course, base 7, just remember that. Because all of this that we're doing right now is in base 7. So let's just make sure that we know that. So base 7. And then what's next? Okay, we add 2. Now, we could add 2 in base 7, or I'll just, remember 15 base 7 is actually just 12. So what's 12 plus 2? It's just 14. 14 base 10 is just 20 base 7, right? Because it's 7 times 2. So I'll just say, okay, 15 plus 2. If I say 15 base 7 plus 2, that's actually just equal to 20 base 7. All right. Next thing we do is we're going to multiply. Oops, I should probably do it like this. Multiply by 3. So what's 20 base 7 times 3? And obviously 3 fits in base 7, so we're fine. So we have 20 times 3. And what's 3 times 0? It's just 0. 3 times 2, that's 6. And since 6 fits, we don't have to do any conversion. Okay, so it's just 60. It's not too bad. So that's just 60. And then what's next? Well, we add 0, right? So nothing changes. And then what? We have 60 times 3, right? So I should probably add this arrow here. 60 times 3. So what's 60 times 3 in base 7? Well, let's do it out here. So 60 times 3, that's 3 times 0 is 0. 3 times 6 is 18. Now, it's not actually 18, right? Since 18 doesn't fit into our base 7 system, we need to convert 18 into base 7. So what's 18? It's just 14 plus 4, or 7. 2 times 7 plus 4 times 7 to the 0, so that would be 24. 24, right? So that would be 4 is added for 60 times 3. So then let's do that, and that equals 240 base 7. And then what's next? Well, we just add the 1, right? So add 1. And then finally, we get 241 base 7. So we could go check this again by converting back from back in a decimal and then just comparing to the original thing. But that's it, you just have to do the calculations there. I am kind of working in decimal in my head, right? Because that's the easiest one for us to do. It's really easy for us to keep track of the values. But, we're not actually writing it out like that. I'm still doing those conversions here, right? Like 18 to base 7, 12 to base 7, etc., etc. So that's how you do it from a small base to a bigger base. Now let's go to this other example where you're doing it from a big base to a small base. Now, if you actually think about this, when you try and expand it in the same way that we talked about before, right? You take the first digit times the base, and then you add, the next thing. What happens here? Well, the problem is, base 7, again, base 7, since we're converting to base 7 again, only has 0, 1, 2, 3, 4, 5, and 6. But 9, 9 doesn't fit into base 7. So we're going to have to convert that 9 into base 7 here. So I guess technically you could write it out like this, but let's just convert it first. So what is 9 in base 7? It's just 9 is equal to 7 plus 2, right? So that would be 7, 1 times 7 plus 7 to the 1 plus 2 times 7 to the 0. That just means that it's 12 base 7. So 9 is just equal to 12 base 7. So let's convert this 9 into a 12. I guess I'll just circle it there. That's where it comes from. And then what do we need to do? Well, what do we add? We're going to add the next digit, right? So the next digit is a 7. But of course, we don't actually have 7 in base 7. So we need to convert 7 into base 7. So what's 7 into base 7? Well, it's just 7 to the 1. 1 times 7 to the 1 plus 0 times 7 to the 0, which is equal to just 10 base 7. So we're going to put, I guess I'll just circle it here, plus 10. All right, so that's what we have to do. And then multiply by the base, which, again, we're still working in base 9 right now, but it's not base 9, it's base 12, which is, I think, a little bit confusing, but it comes from this part here. And then what do? Well, we add the last digit, which is just 2. Well, 2 fits in the base 7, so we're good. And so now you can see every single digit here actually fits into base 7, so that means that we've done it correctly. And then we just do the exact same thing that we did before. Now we're going to start working in base 7. So base 7, and we're going to work inside out, right? So what do we have? We have 3 times 12, which is what? That's 36, right? So that'd be 36 plus 10. And right now there's no issues because 3 and 6 are both found in base 7. 1 and 0 are found in base 7. That's good. This is 46. 36 plus 10, that's 46. There's no issues because we've got it here. We have 4 and 6. And then what's next? Well, we have to multiply it by 12. So that's going to be a little bit more challenging. But how do we do that? Well, I mean, we learned how to do multiplication in different bases. So how do we do that? Let's write it out. 46 times 12. And that's base 7, base 7. So here we're going to do it. So what's 6 times 2? That's going to be 12, which is too much. We can't hold 12 in base 7, so we need to convert it. So what's 12? It's equal to 7 plus 5, so that would be 1, 5, right? So we're going to take that last digit, carry the 1. We get 2 times 4, which is 8, plus 1, that's 9, and then 9 in base 7, which, again, you can convert it again, but we already did it before. It's just 12, right? So we're going to take that first digit, carry the 1, and then there's nothing there, so we just add the 1. Now we shift, add the 0, and then we do the multiplication again. So we do 1 times 6, which is just 6. That's fine. That fits into base 7. 1 times 4, that's fine. That fits into base 7. And then we just add. So what do we get? We get 5 plus 0. That's 5. 6 plus 2, that's 8, but that doesn't fit into base 7, so we need to convert it. So that's 7 plus 1. Well, we know that 9 is 12, so 8 should just be 1 less, right? So that's just going to be 11. You could also see that here, right? It's 1, 1. So they're going to take that last digit, carry the 1, and then we have 4 plus 1 plus 1, that's 6. So that should be 6, 1, 5. So that means that 46 times 12 in base 7 is going to be 615. Then lastly, we add the 2. And what's 615 plus 2 in base 7? You might want to say 617, but again, it's not going to be 617 because we don't have 7 in our base. So we're going to have to do that here. So what's 615 plus 2? Well, it's going to be 7, but 7 again, 5 plus 2 in base 7 is going to be what? It's just going to be 7. It's going to be 7 plus 0, which is actually just 1, 0. Right? And so we're going to take that first digit, carry the 1, and then we have 2 and 6. So that means that is 620. So here we go. We have 620 base 7, and that's how you do the final conversion. So that means that 372 in base 9 is 620 in base 7. But, we did all the conversion direct, and I am kind of doing it, in my head, but I'm writing it out here just to make it a little bit easier. You do have to do some extra stuff, so it is good to revise your multiplication in different bases. But once you get the hang of this, it becomes really easy. And quite honestly, I find this a bit more simple than using successive division, but you can use either method.